So this is one of my many examples of recurring relationships or recurrence relationships, where basically you have a rule which goes round and round in a loop, generating more and more numbers in the pattern. And I mentioned that it's one of my many examples of recurrence relationship because I want you to check out the easier examples before you check out this example. Go to my website to check them out. It's part of the arithmetic series topic. So, carrying on, in this particular example I want to talk about periodic patterns, how these recurrence relationships can produce periodic patterns, and you need to be able to spot them to be able to work out or answer the questions, really, these kind of questions. So the question says, here's a recurrence relationship, un equals 10 minus un minus 1, and the first term u1 is equal to 8, and find out basically the 100th term. That is the question. So let's start generating a couple of terms. Now this, I want to say, is a little bit strange compared to some of my previous examples, because I normally say un plus 1, n plus 1 down there rather than n, is equal to 10 minus something like un. But it means the same thing as that, you know. This one is saying the nth term is equal to 10 minus the term before it, the n minus 1th term. If I had n plus 1 there and just a plain old n there, it would say to get the term after the nth term, i.e. the n plus 1th term, you have to do 10 minus the nth term. It's just another way of saying the same thing. So let's just start generating the numbers. So I've got term 1, u1, and I need to get u2. So how do I get u2? I just follow the rule. So u2 is equal to 10 minus the term before that, which is u1, so 10 minus 8. 10 minus 8 is equal to 2, so u2 is equal to 2. Let's get u3. u3 equals 10 minus the term before that, so 10 minus u2. And we know u2 is equal to 2, so 10 minus 2 is 8. So u3, or term 3, is 8. And then we do it again. It gets a bit boring. Hopefully you realise that basically the pattern is repeating, like we were expecting. It's a periodic pattern. So term 2 is equal to 2, term 3 is 8, term 4 is 2 again, and basically you realise that the even terms, like term 2 and term 4, are 2, equal to 2, and the odd terms are going to be equal to 8. You can try it out if you really need to. Probably good to try out stuff by yourself, and you could even use a bit of algebra to try to figure out or prove to yourself that it really is a recurrence relation. I mean, it is a periodic pattern that keeps repeating. Basically, the patterns keep going 2, 8, 2, 8, 2, 8, and I'll leave that as a little challenge for you to do. It's good to be able to think for yourself, figure out stuff for yourself. But I'll give you a little tip, I suppose. You could replace this with a k. Yeah, so you got 10 minus k, and then keep substituting it back using this recurrence relationship and see what happens. Anyway, so you get the idea that even terms are equal to 2 and odd terms are equal to 8. So if you look at this, I want term 100. That's an even term, so it's got to be equal to 2